Hi, welcome to Bushton Manufacturing. I'm Nihilus Orth, one of the co-owners of Bushton Manufacturing, and we're here to start talking about our BM series scroll saws. Let's go over some of the basic features of it. The traditional Hawk rear tension set cam, the front release cam for changing your blades, the Hawk pressure foot, the lock line air hose, which is long enough we can adjust it anywhere we want it. The rubber bellows operated by the motor of the saw off of the arm. Now on this side of the saw we can see our on-off switch, our variable speed control knob, our thumb screw that allows for the height of adjustment of our pressure foot. Our blade holder uses T-handled thumb screws top and down here on the bottom, which you probably can't see well. We'll show you more on that here in a bit. Our table is capable of tilting 45 degrees either way. As I said, we have the 45-degree tilt both directions, not just one. In order to do it, we want to make sure we get our pressure foot out of the way. We have our knob underneath here, which will allow us to tilt the table. We loosen it, tilt the table either direction, a full 45 degrees. However, down here on our blade holder, our blade holders are removable. We will need to flip the blade holder from the thumb screw being on the right over to the left to tilt it down to the right. When setting our saw for square, it's best to use a small square to set in here and judge it, as opposed to using your miter gauge on any saw. We want to make sure that our saw blade does not wobble side to side as it goes up and down. To do this, I've set my square beside it, and I take and turn the motor such that the blade goes up and down, so we see that that change of the gap never changes. On a Hawk scroll saw, we can adjust the tilt of the blade front to back. To check it, I'm going to set my square against the back side of it here. I'm going to rotate it to the top. It pushed my square back. Now I'm going to rotate it back to the bottom. I see that our square, the bottom was in too far, so let's push her back up to the top. Down underneath here, in the end of it, we have an Allen wrench stuck in there. By turning this, we can adjust that blade in or out. Now I can go back to the top and check this. And I see we have a gap at the bottom, and we can unscrew it further. And do the same. Now we are very close. When I get the arm right in the middle, there is about a 9/1000th of an inch gap in there. Being a long-throated parallel arm saw, we have a very short front-to-back motion, whereas other saws, such as your DeWalt's and the like, have a very small linkage pivoting way out here, gets a lot of front-to-back motion. This lesser motion allows for a lot sharper corner to cut. However, that front-to-back motion allows the sawdust to clear better. To compensate for that, we can cause the front-to-back motion by merely going back and giving this several turns. And we can tilt our blade however much front-to-back motion we want. The more motion, the faster it's going to cut, the better it's going to clear the sawdust. The less motion, the sharper the corner. So you'll want to set that to your projects. Most of the time, I like to be able to cut a sharp corner, not as worried about how fast I can cut. Now we're going to talk about some of the improvements over the current BM series of the Hawk scroll saw over the old Ultra series. This is one of 9 motors that RBI had used on the saws that we have found so far. This is a 5th horsepower, max horsepower, DC motor. And on the end of it they put this block. It has a bearing and a flywheel. This is actually not a counterweight. It is a flywheel for attaching the pitman arm to the end of it. This is screwed onto the end of the motor. There is a flat on the end of the shaft. The set screw that is inside here had to be screwed directly onto the end of the flat. If it did not, it caused troubles. Also, you have a bearing here, you have a bearing on the motor here. Draws a lot of power, generates heat, causes problems. It is also something you want to avoid. If that set screw was not on the flat properly, it would start pivoting on the shaft. And people would tighten it up and it would just wear the end of the shaft out on the motor. Also, the bearing beside the bearing, we had a lot of motors coming back in where the shaft was broke just inside the motor between these two bearings. To solve these problems, we went to this motor. This motor, as you can see, has a large shaft in it. It is a large bearing on the end here. There is no need for a second bearing to hold the up and down thrust. We are using actual counterweights. We make multiple different sizes of the weight. This one's for a 20-inch saw. This is for the 26-inch saw. There was a smaller one for the 16-inch saws. The counterweights slide onto the end of the motor. Notice the pitman arm attaches directly to the motor. This also cuts down on any imperfections as far as the angle here, thus helping to reduce and eliminate the vibration of the saw. RBI was using small plugs to plug the motor into the controller. Many of the motors we are getting in had a problem. It was the plug itself. Therefore, we now plug the motor inside the controller. Each controller is set to that specific motor to guarantee its accuracy as far as how well it behaves, as far as controlling speeds and having the proper maximum and minimum speed of the saw. Continuing with our improvements of the BM series versus the old Ultra series. This is a new BM series lower arm. This is an old Ultra series lower arm. The Ultra series, they removed a little bit of weight by hollowing out the bottom. We have hollowed out the sides, created an I-beam shape. This arm is a third lighter than this arm. Also, the bending motion of the saw, that is, it's wanting to go this direction. This arm is stronger and stiffer than this one. It is not as stiff in the side-to-side motion, but in all of our measurements and checking and testing, it was an insignificant difference in the amount of blade deflection caused by this arm being lighter in the side-to-side motion. The up and down motion is far more important. Next, we changed the blade holder. This blade holder is larger and uses the same 1/4 thumb screw as the upper blade holder. The old Ultra series used a 1032 thumb screw, a much smaller thumb screw, and a lot harder to get tightened compared to this much larger 1/4 thumb screw. When we were talking about the front to back motion of the blade, the old Ultra series had two positions, one that was vertical, one that tilted the blade. Once again, tilting the blade gives more front to back motion and therefore will clear the sawdust better and allow you to cut faster. The more straight up and down of the blade, the less front to back motion, the sharper you can turn. Here on the BM series, there is only one position for the blade holder. However, by inserting an Allen wrench into the end of the arm, we can adjust the distance, therefore squaring it or putting a slope, front or back, on the on the blade to allow for you to optimize how much tilt you want to your blade so that you can cut adequately sharp corners and still cut as fast as you can. On the back of the arm, the old Ultra had the V cut for the wedge pivots to rock in. The new arm, we have an insert in there that can be replaced when you replace your wedge pivots. The old Ultra arm, if you would send your saw in to be rebuilt, we used to remachine that V. Now what we do is we take the same insert that we use in the BM series and drill it out on the Ultra arm so that we can insert this insert in here. That'll allow for less problems here. As that wears, it results in you having fluctuation in the tension of your blade. By being able to change them both, your blade tension will stay a lot more stable during the stroke of the saw. The more stable the blade tension, the less pull out and breakage you will have. On top of the wedge pivot belongs this little nylon washer. This nylon washer needs to be kept clean and dry. That is to allow the cam handle to operate cleanly and freely. But if this washer gets all oily, the cam handle will want to spin and loosen. So this washer is rather an important little aspect on the back end of your tension rod of your saw. Now, if you're having problems where the blade wants to pull out of either the upper or lower blade holder, there are certain things we need to check. Number one is going to be, is the tension during our stroke remaining very stable? That is, let's go back to the back of the saw. Back here, the tension can be released and while the saw is running. That is, this handle could unscrew. That is caused by this nylon washer that is underneath this cam handle being of poor quality. That is, it is getting dirty and slick. It has to have enough friction to hold that cam in place. Also, the wedge pivot here into the insert below it, that needs to stay a good sharp point. As it wears, the fluctuation of the tension in the blade during the stroke can start happening. That will cause blade pullout. Then we get back to the blade holders themselves. All the blades are oily. You slowly get a little bit of oil on the tips of your thumb screws that hold the blade. If you haven't used your saw in a long time, you can potentially get some rust on the tip of the saw blade. Here I have a thumb screw. I've applied a nut to the end of it to help me hold it. What I want to do is clean the tip of the thumb screw. To do this, I'm going to take a piece of 80 to 100 grit paper. While holding this, setting it so that I am barely below the nut, using the nut to help guide me. I sand off the end of it. That'll remove any rust or oil. This has to stay square. These are machined off square. If they are not square, the blade will pull out. At that point in time, then you would need to replace the thumb screw. If this does not do it, on the opposite side of the blade holder of the thumb screw is a flat point set screw. That is Loctited in. We do not recommend that you pull those out. If it's the thumb screw or the set screw is too bad, or the threads are wearing inside the blade holder, that is when you will need to replace your blade holders. For cutting fretwork, we're able to top feed or bottom feed. This is in part due to the lower blade holder and the lower arm sticking out through the miter gauge, so it is in front of it where you can easily reach it. Now, in order to top feed, we need to release the front cam, release the tension, Loosen the blade holder, and I can feed through the bottom as so. Insert back down, tighten it, relock it. That is bottom feeding. Now to top feed, I need to release the cam. Now I am going to loosen the blade holder down here on the bottom. That'll allow me to stick my blade through the workpiece on the top. I slide down in. By feel, I line up with the hole in the blade holder. And once again, tighten the blade. That is how we can top or bottom feed.